Hello Internet, today we have this RTX 6000 Pro. Yep, it's a $10,000 graphics card that is not used for graphics, but rather for crunching numbers. What's interesting about this particular one is that it looks identical to the Founders Edition. The only difference visually is obviously the logo, the markings, and it also has a shiny, polished top-bottom inserts, as you can see here. All shiny. But other than that, it's nearly impossible to tell which one's which. And that's why customers sent two, because we might need to get some donor parts off of that one in order to fix this one. Now, what is wrong with this one? If I'm not mistaken, customer said something along the lines of physical damage to the connector or something rather. So let's take this thing apart, see what's going on. We're gonna start by removing the I/O shield. Like so. And then there's supposed to be a single magic screw that holds everything together. And if I'm not mistaken, it is this screw here, just kind of sitting by itself, like so. So it's this screw between the two display ports. And then what that theoretically should allow us to do, it's going to allow us to lift the bezel. Let's see if I can grab it somehow, somewhere. There we go. And then that just comes right off, like so. So I'm going to move that out of the way. And that gives us access to several holes here. So it looks like we're missing a screw in here. It's okay. I continue on anyway. There's 1, a 2, and a 3. And I believe the whole thing should just slide out of the way. There we go. So there's one piece. Move that out of the way. Second piece doesn't want to move out of the way. There we go. And now we need to get this guy out. The PCI Express adapter. The absolute disaster of engineering at the NVIDIA headquarters. Probably the number one reason why these cards fail. As a matter of fact, every single Founders Edition GPU has been nothing but a problem. 3090, for example, because the GPU itself came earlier than other vendors, such as MSI, Asus, or what have you, they have problems with the memory chips. Almost every Founders Edition 3090 comes with heat-sensitive Micron memory chips that will short a lot of times after doing a core reball. Sometimes half the chips die, sometimes none of the chips die. It's just a gamble. Sometimes all 24 chips die, so imagine paying the price for 24 chips. It's just not pretty. Let's see if I can pry here against the power connector. There we go. So that comes right off. Okay, nothing unusual here. I can probably do some visual inspection on the PCI Express slot or the adapter, this connector here, so that we might not even have to take this whole thing apart to actually test this. And oh yeah, there we go. So it looks like we do have a problem right there. So it looks like this pin here is slightly damaged, though I do not really see anything like super serious because the connector is bolted to the board. As long as there's connection, I don't even think we're gonna need a donor board for this because the pin is still in its place. Yeah, so the pin is still in its place. I see absolutely no reason for the need for any kind of a connector replacement. But just one single pin that I see here, this pin here, I do not know if you can see this, but it is kind of sitting a little bit crooked. So that might actually be the issue. If we focus here, you can see, let me a little bit more light in there. There we go. That pin definitely could be a problem. So we could try to sort of get it back to the straightness, to its former glory. Then we should also get rid of this broken piece of plastic. Shouldn't cause any kind of issues. I do not think so. Let's clean that up. All right, so that looks good. Maybe a little bit more. I see absolutely no reason for connector replacement, but that could just be the tip of the iceberg, because just because the connector is now looking okay doesn't mean the male end of this connector is okay. So let's have a look at the male end, and the male end looks okay so far. Yeah, the male end looks absolutely flawless. Yeah, I see absolutely nothing to be concerned about the male end of the connector, other than maybe a little bit of dirt, debris, or whatever. So I'm a bit concerned about the display. Pop that open. Yep, the display connector looks fine, other than just the thermal pad being a little bit too close to it, and maybe slightest amount that got in there. But I don't think it actually got anywhere near that would cause any sort of issues. Let's have a look at the male end of this. But the male end of the connector looks a lot worse. It actually looks like we have some stuff in there, so we can definitely clean that up. That'd be kind of cool if all this is just dirt. It'd be the easiest RTX Pro 6000 repair ever. No need for a connector, no need for a reball, no need to diagnose the circuitry, none of that. Just get it clean and it should work just fine. Wouldn't that be amazing? And let's see if we... Actually, let me go ahead and attach this board here temporary, because I do want to power this thing and see what it does. I can't really... Well, can I? Yeah, I guess I can. I'm just kind of debating here whether or not I should reinstall the back plate that would serve as a support for the connector. But I think if we just secure that connector at the base, like here, it should be okay. All right. Let's power this thing on, see what it does. Gotta be super careful here not to bend anything. This thing is not repair friendly by any means. And the amperage is kind of jumping all over the place, but that's good. So looks like we are finally safe to try to boot this thing and see if it posts. It's gonna hold it like that, so I would not apply any kind of stress on the PCI Express connector. Push the power button and absolutely nothing is happening. Like nothing. Very interesting. What am I missing here? I should have a reaction. I'm not sure. Maybe try HDMI. Do we have HDMI? Oh, we don't have any display HDMI ports on this thing. Okay. Let's try a different display port. First one. So in theory, it should work. But in practice, absolutely nothing is happening. Means let's go ahead and boot into the Linux, see if we can at least detect this thing. A definitely interesting turn of events. Okay, let's do a LSPCI. And yeah, the NVIDIA controller is there. Very interesting. Okay, so we're gonna go reboot. And then we're gonna go into Windows, see if the GPU would actually post, or detect it rather, install the drivers and see what happens then. So it looks like we do see the video controller. That's very good. That means that the device is detected by the operating system or Windows, not just Linux. That's promising. Let's wait for the driver to initialize, see what happens. Alright, so this is what the driver installation progress told us. We have an NVIDIA RTX PRO 6000 Blackwell Workstation Edition installed. We should restart the PC, because a lot of times if the GPU is still reporting errors, the device manager shortly after the driver installation may not show you anything, any kind of errors, especially when we're using iGPU to get the display from the motherboard. Basically because we're not getting any display from the GPU itself, but we're getting it from the CPU. Once the drivers are installed, we're not going to be able to tell whether or not there's a problem until we restart. It's just it's a Windows issue. But after restart, if we see any kind of error code 43 or anything like that, kind of interesting. It's not showing under the display adapter. It's not a display adapter. It's not under here. It's not going to be under system. Obviously not going to be there. Very interesting. Kind of wonder if the GPU-Z will detect it. Yeah, the GPU-Z is not seeing it. So it looks like it just disappeared from the device manager. It's supposed to be here, but it's not. It's not under the display. It's not under the sound, video, and game controllers. It's not going to be under here. It's not going to be here or whatever. Yeah, very interesting. Okay, let's shut this thing down. And what I'm thinking, this is probably the issue with the PCI Express X1 that we're running it in, because right now we're connected through the riser. So I'm gonna go ahead and connect it straight into the PC. See if that changes anything. Nope, it's still not there. We do have a video controller. Okay, never mind, because we need to reinstall the drivers again because we changed the slot. So we're gonna wait for that to happen and then see what changes. All right, so it finally identified the video controller, and there we go. NVIDIA RTX 6000 Pro. Like I said, this message here can be misleading. But I can identify whether or not that message is correct by simply running GPU-Z, and if the GPU-Z is reporting memory store capacity and sensors and things like that, then that means that the device is actually working. So let's go and see what happens. So yeah, we're not seeing anything here. So like, as you can see here, no memory, no nothing. All we see is NVIDIA, whatever. So like I said, that message that you see here in the device manager is misleading. We actually need to restart PC, and then it's going to give us the error code 43. So as a matter of fact, let's go and do that so that you can see exactly what I'm talking about. All right, we are back. Let's go into the device manager, display adapter, and the thing isn't even there anymore. Interesting. It is exactly the same behavior as we've seen before. It just disappears from your device manager after you install the driver. Very interesting. But regardless, I think we know what the problem is. Let's go and shut this thing down. I'm gonna have to bring out the newer system with the PCI Express version generation 5 in order to run a memory test. So let's do that real quick. And the motherboard just does not want to boot at all. Alright, so I think we've seen enough. Let's go and force this thing shut down. The GPU is not posting under no circumstance, basically. It's being detected correctly, but as soon as we install drivers, it disappears from the device manager, leading me to believe that we have not just the connector damage, but we might actually have the damage under the core. And I only hope that that damage is not too significant, because if it is, this RTX 6000 can go straight into the scrapyard for several reasons. One of those reasons is because where are you going to find a donor board for such an expensive card? I do not know. I most definitely do not have one. Just because 5090s and this Blackwell 6000 Pro, whatever you want to call it, look identical, they are not identical on both sides. As you've already seen, this one has memory chips on both sides, whereas 5090 Founders Edition card has memories only on one side. So clearly I cannot simply swap the boards. My biggest fear at this point in time is all that liquid metal that could be sitting under there, and it is not there. So maybe this GPU does not come with liquid metal, unlike the 5090 Founders Edition. Yeah, it looks like it does not. Otherwise, there would be a rubber seal here, like you would normally see on a 5090s. So, okay, definitely a plus. Makes this thing more repair friendly. So, but regardless, we know that the board is powering up. We know that the device is detected. So, the only thing that we're having issues with is what seems like consistency problem. It's very likely that the problem is not that, but rather the red pads under the core or something along those lines. So let's go ahead, clean this thing up. I want this absolutely clean, or at least as clean as possible before we start torturing this. So that way none of that material will be baked to the board even harder than it already is. And hopefully after some BGA work, we'll get this thing to work properly again. Alright, so here's the board cleaned up. So because the main source of damage came from this general area, it makes perfect sense for me to try to maybe lift this chip and maybe this chip and see if anything change, if I find anything wrong under there, and just get them reballed. Maybe there's just something as simple as a micro crack. So that will probably be the easiest thing to do. So I want to go and try that first, and if that does not work, then most likely the damage is far deeper than just these two memory chips, because at this point I can't even run the memory test, though given the fact that the motherboard is refusing to boot off of this card, I think it makes perfect sense to not try anything other than getting that board reballed right away. So, or the core rather. So let's do that. See how it goes. Okay, the reball is complete. Alright, let's power this thing on. And the issue, immediately I'm running into an issue. How do you power this thing on without that little adapter? For that reason, I've made this contraption that holds the adapter. And all I need to do is snap it on there like so. It's supposed to be perfectly aligned. Fits like a glove. Absolutely perfect fit, with the exception of the display adapter, but we can ignore that for now. We just want to check for power. And I will also be redesigning this thing to make it a little bit more diagnostic friendly, because right now I can't measure any voltages on the back of the board with this. So it's just a prototype that I really never had time to play with. Alright, so here goes the power. And we're going to arm ourselves with the thermal camera so that we can spot any abnormalities before they do any kind of damage. And here goes nothing. Looks pretty good to me. I don't see anything criminal. Now, here's the thing. I don't know how I didn't notice it before, but if we were to look over here, it looks like there's nothing really wrong. But at the same time, if we look closer under a microscope, what we're going to see is that we're going to be seeing two pads, and I believe this used to be a coil, and such as this one here, and that coil must have got knocked off, and that basically explains all of the symptoms that we're having. Well, not all of them, some of them for sure. So let's go ahead and steal one of these coils from the donor board. Let's see if I can just snap one off the same way they snapped. No, I can't even snap this thing off. Huh. I don't know how they managed to break it off of it so easily, but regardless, I'm gonna steal one of these coils off of here and solder it on there, and then we're gonna try to boot. Alright, so we got the coil on the board like so. So now let's see if we can boot the card. At this point, I'm not really worried about getting any kind of display out of this. I just want to go into the device manager and see if it's going to show up there, and if there be any errors or anything. Basically, if the GPU-Z would recognize it, then I will go ahead and put it back into the cooler and see if we can get any kind of display out of this thing. Alright, let's go into the device manager. Do we have our... Yep, there it is. Showed up. I bet there are no problems. We didn't have to wait for the drivers to initialize, and if the GPU-Z reports all of the data, then we have a fix. Though at this point, I'm not exactly sure what was the fix, whether it was the coil or the reball or both. My guess, it's both. So, yep, we have all of the sensors. So, I mean, we could probably try to run something very light, like maybe Heaven, see what that does, just to see the dynamics of the clock and whatnot. Just gonna run it for a couple of seconds, and it runs fine. Okay, so let's go ahead and turn this thing off. I'm gonna go ahead and assemble this into the cooler. So as you can see here, I am definitely struggling figuring out the pad thickness, hence why originally they went with a thermal putty, but I do not want to use thermal putty because it's going to get under the chips. That's going to cause problems. If there's any further repair that needed to be done, it's going to be a lot of problems if the putty is used. So it looks like the 1mm pad would be a perfect fit, but for whatever reason, it just does not seem to have enough imprint on the pads that would give me an okay to use 1mm. It looks like it should be perfect, but for whatever reason, it just wants a little bit more. So I know that 1.25 is going to be maybe too much. It's not going to be too much. It's going to be a little bit on the high side, but at the same time, I would rather be a little bit on the high side, and the pads will somewhat conform. So kind of there's a little bit of room for error, basically. And I think I want to do even thicker pads on this end here because of the ridges. Top of the ridges is the same height as everything else, but the bottom is not, so that's going to allow the pads to sink in even further down, which is not ideal by any stretch of imagination. I do not know why they did it this way. This is probably the dumbest way to do it. Definitely not the easiest pad job I've ever done, and I'm already sitting here trying to figure this thing out for probably an hour. Alright, so that took a while to do all these pads. Right now what I want to see if whether or not all of the data lines are registering through the connector. Looks like all of the data lines are registering, so that's good. Now let's go ahead and plug this thing in and see if we can get the display out through the one of its display ports. And here we go. Still nothing. Absolutely no reaction to the display adapter whatsoever. And we heard a beep, so that's probably a happy beep. Okay, let's not worry about the display adapter right now. Let's go into Windows and see how the card behaves. I want to see it work. I want to see it run some sort of a load test, and then we're going to be addressing the issue with the display adapter. So we might have to figure something out here. I do have a spare from the donor card that the customer had sent, so we'll see if we need to use any of that. Or maybe there's something else that's wrong with this card. Okay, what I want to see is the 16 data lines are all active. Yep, all of them are there, so we're good. Let's go ahead and probably run a firmware to see how it holds up the temperatures so we can see whether or not the pads were done correctly. I am actually guesstimating that the core is going to go a little bit hot, but the pads will settle once they warm up, allowing the core and the cooler to contact better, but we'll see. And as you can see here, unfortunately, we have no access to the hotspot temperature, so I have no idea what is really going on, but I don't see any crazy spikes, so I think we're okay. Memory temperatures are definitely on a good spot, so we can increase the load. Let's do 1920 by 1080. See what that does. We're still nowhere near its total power consumption. Very interesting. This is a very interesting graphics card. Let's see if the memory test is going to be loading this a little bit more. It's kind of funny how it actually takes a while for this thing to enumerate 96 gigabytes of memory. Usually the test would have ran by now. And I'm not even sure at this point if this software is even supporting this graphics card. It might not. It sure does take a while to allocate the memory in order to run its thing. Oh, there we go. That took a while. Yep, so it looks like this card is more memory intensive workload than the graphics. As you can see here, we're 90% on the TDP running a memory test, so that makes a lot more sense. Definitely not going to be a gaming card by any. I mean, you can still game on this, obviously, but it looks like, judging by the way that the power behaves, it looks like the memory load is where most of its demand will be fulfilled. So, and the fact that we're running the test and it's not giving us any errors is really good. So almost 600 watts. I wonder if I can add firmware on top of that. And the firmware just stalls the entire thing. Yeah. So we're good. The only thing that I gotta figure out right now is how do we go about solving the problem with a no display. So let's have a look around and see what is it that's wrong with this. Why does it not display? It's completely, there's absolutely no reaction to the ports. And this thing is hot. Ooh, this plate is hot. That's good. That means that the plate is taking a lot of heat away from the board or from the memory chips. So that's good. That means I picked the right size pads. Right, so we know for a fact that we do not have any problems with the PCI Express adapter board. All of our 16 lanes are working, but we definitely have a problem with the display. And my best guess is that the ribbon cable is probably damaged. The issue with the cable is that it goes around the case inside and it's glued to the shell. Not easily removable by any stretch of imagination. But it looks like we might not even have a problem with the ribbon, but something else. Let's have a look at that connector one more time. See if we can spot anything. And just like before, I see absolutely nothing wrong with this connector. Maybe a little bit of dirt, and that's it. Interesting. Okay, let's take a look at the connector on the other side. And in here, everything looks fine. Alright, so let's try a different connector. This connector here actually has HDMI port, so I don't know if that's gonna work. So my plan is basically get this out of the way. I really wonder, I think someone took this apart and I think they broke something. So I wonder if we can, it's not gonna be, I have no idea. Alright, so we're gonna try, basically we're gonna try to repeat the test, except this time we're gonna attach a different connector. See if we can manage to do that somehow. Absolutely no reaction whatsoever. Okay, let's wait so we can turn this thing off. Alright, so nothing. Let's try display port. My guess is that we're missing 5 volt. Okay, there we go. So display port actually reacted, but it does not display anything. Okay, that's interesting. So we do get 5 volt. Try here. Nothing. Alright, so we're finally getting some reaction, but that reaction is just not getting us anywhere. See if we can remove the whole assembly out of there. Not exactly sure how, but I think we actually have a damage on the connector itself, so on the ribbon cable. Okay, so I spent a good amount of time butchering this thing, trying to get this thing open, and the design is absolutely ridiculous. I still don't know how the latching mechanism works, but it seems as though you have to remove the fans in order to release the two halves together. And so, according to what I'm seeing here, this latch in particular had wear marks from the beginning, and that wear mark actually matches the damage on the ribbon connector right there. So, which means that whoever tried to take this thing apart before must have damaged it. So, we're gonna have to fix this ribbon cable, and hopefully the damage is only there. I'm guessing it's just one of the power lines that's cut, and so that should really be it. I do not know if I can reuse any of this because this connector here is definitely looking different. So, but I don't know. Maybe it's worth a shot. Maybe we can just swap this. That connector is also connected with that same type of nonsense. The retaining clip. Let's see if just swapping this part with this one will solve the problem. I do not know. Now, I will probably be getting a cooler from the donor board because this one kind of got damaged to a point where I cannot even reliably use this, I don't think. Alright, so the repairability of this design can be described in one word: garbage. Incredibly difficult to access anything. Requires you to disassemble the device several times to do basic diagnostics. So let's see if replacing the ribbon cable actually going to work with display adapters that are there. The reason why we were getting nothing last time is probably because I forgot to plug in the adapter, so I probably wasted a lot of time, but who cares? We're gonna learn something one way or another. So let's see. Okay, we're getting display. Perfect. I just want to make sure that I'm gonna get display on the first and the last port, so that way we know that we can safely replace the ribbon, and then that the connectors are 100%, the board with the connectors is compatible with the rest of it. Okay, perfect. So we got a fix. The GPU is working. All I gotta do now is put everything back together if I can. Hopefully nothing breaks along the way. So we have a ribbon that was sliced by someone who tried to take it apart before. Looks like we have some electrical tape in here. I just noticed that. That's covering, well, it's not covering anything, but it's still there nonetheless. So right now what I'm interested in is to see how easy or not it actually is to get that cooler out of there. So let's go ahead and figure this out. So we probably need to start with same thing as before. We need to remove the I/O, then we need to remove that one screw behind it, and then the magnetic bezel. So we just want to make sure that we do not mix different things here. That screw right there. Okay, so now we should be able to lift this somehow. There we go. There we go. Alright, so the bezel is out and we should have access to some of the screws. 4 screws in the middle. We'll remove the sliding covers like so and like so. So now I think we need to remove 4 more screws, actually more, because we're going to be getting the entire assembly with the board. So let's just remove all of the screws that we're seeing, because I still need to get that board separated from the cooler, because we are reusing the cooler and not the board. If you ever buy a 5090 Founders Edition and you see signs of liquid metal like this anywhere outside of the card, it's a scam. 100%. The core and the memory are harvested and you are getting scammed. My only hope that there's no damage here to anything really. Doesn't matter. LED, connect that. There we go. Alright, so here is the donor board that we might need eventually. Put that aside. And let's go ahead and figure out how do we go about disconnecting this thing. So we need to go on the other end of the cooler and we need to remove the fans. So the fans are removed rather easily. 4 screws. Don't know exactly why they need to be removed, but it looks like they need to be removed. I guess they're just getting in the way. So that comes out. And another fan. Alright, so flip that over. Don't know what that is. I do not recall ever seeing this. That just fell out from inside there for whatever reason. Oh, that was here. I think it was there. Not sure why, and I don't care. Alright, so now, I think what we need to do now is we need to pry this here and this here. I think. Not sure. That doesn't seem to work. Seems as though I need to pry this here and then this one here. But that doesn't seem to work. Or at the very least, it didn't with the last one. Seems like we need to pry this backwards. I don't know. This one here definitely gets pried this way. But this one, it might be the same. I don't know. It doesn't want to come out. Okay, there we go. I think I see how this comes apart. So it looks like we need to go in here instead. And then in there, what we're seeing is the latch of death that we need to, you see what we need to do? So we need to grab this and do this, I think. Let me focus on there. So that's the latch. It's kind of holding it down. So if we do this, it's supposed to drop. And then we need to do that. Like, who invented this? This is the idiocy 101 right there. Why does it need to be so stupid? Okay, so that came off. So I guess that's how it works. You pry it from here, and then this one, yeah, this one is special because it's got that ribbon running in there. This one is pried backwards. And of course you have to pry against the fence, so you're damaging the fence because some genius out there smoked the good stuff. This is so dumb. Alright, so why did I do this? Because the shell says GeForce RTX, and I believe this one does not. It just says NVIDIA, so we want to make sure that we match. Alright, I need to get rid of all that liquid metal that leaked everywhere. Oh, and also we're gonna have an issue with the pads because the pads are not gonna work here the same way they did over there because the cooler is a little different. So we're gonna have more issues with pads now. So it seems as though it's not directly compatible if you wanted to swap one with another. There are a few little things to note, and one of those things is thickness of the pads. Basically clearances here are slightly different. We got that liquid metal everywhere. All right, let's transfer this thing over. Alright, that should be it for this repair. Hopefully everything went smooth. The cooler was not a direct replacement. I had to play around with some pads here and there, but overall it looks like it could be, it looks like it can be used. So let's go ahead and plug this thing in, run some tests. Hopefully everything holds up. Thank you for watching. Hopefully this was educating. And don't forget to like, subscribe, and we'll fix something else in the next video. Goodbye.